All right. So the first thing is that um, creating a user, I think it's very easy and simple in Kali Linux or any Linux for that matter. So you just have to go ahead and say add user. And I'm going to call it any name that I can recall, BASSAM, Bassam. It is going to ask me for the password. So I can just keep an easy password for now. You can put the details if you like, but I just randomly fill it. And then the user has been created. If I want to add another user, whatever I can think of. And then the user is created, right? So this is the first step, that you have to create a user. The second step is that you have to create a group. So for group, again, add group, dojo 1. And then I can create another group, dojo 2, for example, right? So I have two users and 2 groups. By the way, if you want to see these users and groups, you can actually go to cat/etc/shadow. So basically you can see your users here, Bassam and Salim, and you can see their password. And I think I went through them yesterday as well, right? Okay.
Yeah. Yes, you did.
Yeah. Now the next thing is that, for example, I want, see, the purpose of creating the groups is that if you put some users into that group, they will have the same kind of policies implemented on them. So that is essentially the purpose of creating a group. So whatever permissions or whatever rules you implement or policies you implement on group, they will be implemented on all the users within that group. So that is why groups are really important. Now, for example, if I want to just a minute. If I want to, for example, dojo 1, and then so if I want to assign a user to a certain group, you basically have to use user mod minus a, capital G is for the group. And this is the user, which is a is to append. And then this is the group name, and then this is the username. So I'm basically moving or assigning the user Bassam to group dojo 1, for instance, right? So now basically he belongs to that particular. And similarly, you can do for the other users and the other groups as well. So this is the users and groups part, which you have to do in the lab. The second part was that creating the folders, and within the folders, creating the directories, files. So again, what you will do is that you will log out and log in with one of these users. Like, for example, you can log in with the Bassam user and then create directories. However, I'm not going to do that. I will just demonstrate on this in this particular window that how you create a directory and how you create a files. So let me move to my /home directory. So if you go to the home directory, you can also see the users that I have created. Their directories are also there. So for the root user, he can actually go to any of these directories. Anyways, I'm still in the root user. So let me just make, in fact, let me create it on the desktop. So let me just create a directory called dir1. Okay. And if I go inside dir1, I can actually create any file. Let's say file1.txt and file2.txt. Okay. So creating the user is done. Creating the group is done. Assigning a user to the group is done. Creating a directory is done. Creating a file inside a directory is done. Now the only part is the permission parts that you need to do. Okay, if you want to check the permissions to any directory or any file, it's very simple. You just have to write ls -l or -l. Let me zoom in it for you. Okay. And then you just, if I don't give a file name, it will show me the permissions to all the files within this directory. Now, if you see here, ls -l, it actually shows a hyphen and then rw hyphen and then r hyphen hyphen r hyphen hyphen. Okay. The first hyphen basically tells that this is a file. For example, if I make a directory here, dir2, for example, within this dir1, if I write ls -l now, you can see the difference now. So this is a directory, and the first alphabet is D. So it basically tells us that this is a directory or a folder in as per the Windows. This hyphen tells us that this is a file. Okay, so now you can differentiate between the directory and the file. Now, the rest of the things are basically common starting from here onwards. So if I look at this file number 2, for example, the permissions are read, write, and nothing. So read, write, and nothing means that the user or the owner of this file, he has a read, write permissions on this file. The group to which this user belongs has a read permission only, but the group doesn't have a read, write permission. Others have read permissions only, no write or execute. So X is for execute, W is for write, and R is for read. User, group, and others. If I just open this document, just a minute. Okay. You can actually see, and it is mentioned here that the first 3 permissions are for the user, the next 3 for the group, and then the last one for the others. Okay. Coming back to the permissions. Now, for example, I want to change the permissions for file 2. Okay. And I want to give read, write, and execute permissions to file number 2 for the owner of the file. And then I want to give read and write permissions to the group. And then I don't want to give any permissions whatsoever for the others. How do we do that? If you see these numbers here, so 0 is for no permissions. If you want to give write permission, execute permissions, this is 1. If you want to give, execute permission 1, write permission is 2, and read permission is 4. However, if you want to give read, write, and execute, so 4 plus 2 plus 1, 7. So you can see it here, read, write, execute is 7. If I want to give read and write, 4 plus 2 is 6. And if I want to give read only, then you have to give 4. So let's just go and try to change the permissions of file 2, read, write, execute, read, write, and no permissions. So it's very easy to do it. chmod. So the first 7 means read, write, execute. Then read and write, 6 for the group. And for others, I want to give no permission. So 760. And then the file name. So this should actually change the permissions on the files. If I use ls -l, now you can see the change in the permission. Read, write, execute for the owner, read and write permission for the group, and then no permissions for the others. So this way, and by the way, you might have come across this before. And I think you can use these alphabets as well, like this is read, write, execute can also be done by using plus X, I think, with the alphabets, right? So there are more than ways that you can change the permissions, but in the lab, it says that you have to use chmod and by using this method that I just explained. If, for example, I want to make read, write, and execute for all of them, it's very easy. I will just write 777, read, write, and execute for everyone, and then file1.txt, for example. Now it's read, write, execute, read, write, execute, read, write, execute for everyone, right? Once you are done with this, as per the instructions here, then what you need to do is run a Linus audit. And I'm sure you have done it before in the previous lab, so you shouldn't have any problem doing it again. Okay, now if you guys have any questions, please. Yeah, like if the Psalm said, plus X for all.
Is this a group thing is like the role access control?
Yes, exactly.
Okay.
So role access control basically controls the access of the files or folder or whatever based on what is your role. So the group that you create, for example, you create a group called managers, and then you can create a group called administrators, and then you can create a group called students, and then you can apply permissions based on the role and not per user basis, right? So it is a role-based access control kind of, right? Okay. So like I said, this lab is easy, won't take too much time for you to finish. I have some extra lab for you, and probably that will be interesting for you as well. So the lab, the option lab that I have to do, and by the way, I have seen that you guys are not submitting the option labs. I created the option lab folders for you guys, and I wanted you guys to submit the optional lab. So I want to see who is working. So I will strictly start following those optional labs because, you know, I spend time to prepare them and then demonstrate them. And I don't know if you guys actually are working on them or not. So I want some submissions from you guys if you want to have optional labs from my side. Okay. All right. So the lab that I'm going to demonstrate today is about Ettercap. Before I go and run the Ettercap, there are two commands that you need to run. One is called the echo one greater than sign /proc /sys /net IPv4 IPv underscore forward. Now, basically, by default, the value in this file IP underscore forward is 0. Okay, and we have to change it to 1. The reason why we are doing it because sometimes when we are running the Ettercap, it actually starts killing the traffic. Okay. So in order to do that, to avoid killing the traffic, you have to execute this command. Okay. And if I just want to show you the content of this file, it's nothing. I just echoed 1 to it. So you will only see 1 cat. So by default, it's 0 now. So what I want to do is I want to change it to 1. Echo. Okay, so I have changed the value from 0 to 1 to avoid my Ettercap killing the traffic. Now you can see that the value is 1. This is the first command that you have to do. The second thing that you have to do is that you can use Nano Editor to open Etter.configuration file. So the configuration file of Ettercap. So the path is /etc /Ettercap /Etter.conf. If you open this file, you don't need to make a lot of changes. If you should see the user ID and the group ID, it's 65534 by default. So all you need to do is make it 0. Okay. After that, just save and exit. Okay, so I've done two things. I ran the echo1 command and I just modified the configuration file of Ettercap, changing the user ID and group ID to 0. Now I will start the Ettercap, and it is a graphical user interface. Doesn't look really nice, but you know, still good enough for Linux. Because Linux usually doesn't deal with not very good in the graphics. Okay. So you can see here that when you open it, it says that sniffing at the startup. So it's already enabled. The primary interface by default is ETH0. So it actually detects your interface and says that, okay, I'm going to sniff on this interface. You can say, okay, leave it to default. So no need to do anything here. Just click on this check mark, this accept. Okay. Now, as you can see here that it has loaded the plugins and the fingerprint services and everything is loaded in the Ettercap. The next step is to click on these three dots. And after clicking on these three dots, you can see the hosts. And after clicking the host, you can see scan for the hosts. So what I'm going to do, trying to do is that I'm trying to find out the hosts on the network. As you can see that it has found 4 hosts on the network. I'm going to click the three dots again, hosts and host list. So basically it is going to list all the hosts that it has detected. 36.1, 36.2, 36.130, 36.254. Now, the target IP, you should know. What is your target? So I'm going to select 36.130, which is basically a Windows machine that I have here running on the side. It could be any Windows machine, Windows 10, Windows 7, whatever. So I'm going to add it to target 1. Now, if you know what is the gateway, means to which machine this, to which gateway this machine is forwarding, you can actually select the gateway and add it to target 2. If you are not sure, then leave it like this. You add the target to the victim to target 1 and leave the target 2 blank because it will automatically consider all the other IPs as the target 2. Okay. So once you are done with this, you have to click on this globe sign and start the man in the middle attack, in which you can see on the top is the ARP poisoning attack. Okay. So once I check the ARP poisoning, it will ask me that, do you want to sniff the remote connections? I would say yes. By default. Okay. Now it has started the poisoning and it has started sniffing the traffic of the target if it is sending it to the gateway. As you can see, group 2 is any or all hosts which are in the list. All right. Click the three dots again, view, and view connections. Now what you see here is that it has actually started capturing the packets which are going from 36.130 towards the gateway, mostly because 36.30 is trying to access the internet, some traffic is going on. So our Ettercap has actually started capturing those packets. Now what I want to do is that I will just try to filter out the UDP packets because I'm not interested in the UDP packets. Most of the good information or the good stuff is actually in the TCP. So I'm going to select the TCP. I go to the victim, and you can use the same web page because most of the websites are not using actually HTTP. But this is test php. I will share the link with you in Discord. So what we are trying to see here is that when I enter the username and password, does my Ettercap captures the username and password which is going on in the clear text? Let's find out. So I have not created an account, so I will just use anything. Asad Raza, and the password is 1234567 8. It's not my real username and password, but it actually will show you whether the Ettercap is actually capturing this username and password or no. So if I click here and I go back, well, you can see here that it has captured the password Asadraza, and the password is 12345. If you are interested in looking into the contents of the packet, for instance, you can just double click it. Um, not a good example. Not a good example because there are too many packets going on. So let me just see which one I can. Telemetry. I'll have to go one by one to find out something to show you. So if you see this packet, it actually shows that the victim is actually visiting test PHP vulnerable oneweb.com login PHP page. And it also shows here that this was the packet in which the username and the passwords were captured. Now, the big question that you might be asking in your mind is, okay, this looks very interesting. And, um, you know, uh, and also you can see the summarized information here as well. Username, password, and the website that was visited is this one. I think the question that you might have in your mind is that can we capture the secure traffic, HTTPS, right? If that is the question in your mind, I will encourage you to look for it on the internet and try to see, is there a way that we can capture the SSL or HTTPS traffic? There is a way, but I want you guys first to go ahead and do a little bit of research after doing this lab, optional lab, and then we can discuss it in some other session that, whether it's possible to capture the SSL or HTTPS traffic or not. Okay. So once you are done with the lab, what you need to do is, which is very important because you have already poisoned the cache. And by the way, if I want to show you that this target victim's cache is poisoned, I can open the terminal of the Windows and I can show you ipconfig. No, ERP -A. Okay. So if you check the ARP cache of this victim, and if you look at the MAC address, 0000C2988D7C1, and again the same MAC address, the same MAC address, the same MAC address. Let me show you the Kali Linux MAC address now. If config, sorry. So if you see here, the MAC address of Kali, where is it? So 000C and ending with C1, right? So 000C and ending with C1. What it actually means is that the attacker, the Kali Linux, when I ran the Ettercap and I ran R poisoning, it has poisoned the cache of this victim. And instead of the original MAC address for the gateway, which was different, it has actually placed its own MAC address. So this is Kali Linux MAC address. So whenever the traffic is going from this victim, it will always go to the MAC address because the communication that is happening on the local area network is based on the MAC addresses, right? So that is the reason that you can see all the MAC addresses here belongs to basically Kali Linux. And that is how the traffic is being forwarded to Kali Linux. And then if you remember, I ran the command echo1 and IP forward, which basically means that forward this traffic to the internet, whatever is coming. So this is, you can call it man in the middle attack. You can call it password sniffing attack. You can call it R poisoning attack. And this is really an amazing tool, this Ettercap. You can do other types of attacks as well. You can see here, you can do the ICMP redirection attack. You can do port stealing attack on the switches. You can do DHCP spoofing attack. Means you can pretend to be a fake DHCP server and then start giving IP addresses to the clients so that, again, they will start diverting their traffic to your machine and so on. And there's an option also, SSL intercept. You can, look into it, whether it works or not. Okay. So after you are done, you will stop the man in the middle attack. and you can close it down. Now, I'm done with the demonstration. So if you have any questions, please go ahead.
Thank you.
No questions, guys?
Thank you,
For me, no.
Okay, so now if there are no questions, we can open the breakout rooms for you, and then you can work first on the core lab and then on the optional lab. Okay. Thank you. I will stop the
Okay,
recording.
Mr.